Hey guys, so let's go ahead and get into what we are going to talk about today. So, guys, what I want to do for today's lesson is at this point in the unit, typically we would have been at about the halfway point as far as the material we're covering. Honestly, we've covered most of I guess you'd call it new material, but what the second half of the unit is going to be mostly focused on is kind of what we've been doing this week a little bit, but mostly taking the kind of information or the kind of data analysis that we know to do, like mean, median, mode, range, dot plots, frequency tables, histograms, and applying it to, I guess you call it real world problems or more like situations that aren't just here's some numbers, what does the diagram look like, or what's the mode? More like, okay, you know how to use this stuff. Now take it and apply it to some applicable situation, some situation where you could find this useful, because it doesn't do you any good if only thing it's useful for is answering a math problem, right? There's nothing that it puts a use to unless it can apply to something you're going to see on a typical day or just some situation in your life where it might be useful to use. So you'll see some of those in future lessons. But for right now, we're just going to take a look at this mid-module assessment. And it says assessment, but we're going to take it more as a review of where we've gotten at this point in the unit. So I took a couple pages off of this. There's usually 6 pages on it, but I think what I'm going to do for this one, guys, is we'll just go over 4 pages, 2 front and back pages, and I'm going to use one of them as our assignment, the last page, because I think it'll be a good practice question to see, hey, let's see if we can figure this out. This is kind of a nice look into how to use mean, and let's just say it'll be a good test to see we can apply what we know about mean and go just another step further. And I will kind of give y'all a little bit of an insight into another way to think of mean before you attempt it. And that should be enough for us to at least give it a fair shot. So what we're looking at, guys, is, and this will be on the Google Classroom page, but we're going to be looking at the mid-module assessment, and we're going to look at the first 4 pages of it. It's our notes. So I think this will be I think this fits pretty well. And I think based on the material we've covered so far, I think that this does not contain any questions that are out of our capability of answering. And if you would like, before you watch the video and watch me go over some answers, to take some time and see and give it your own shot and see how you would answer them. And then once you're done and feel like you've answered them as best you can, go back and continue watching this video and see how your answers compare to mine. I think that'd be a great idea. If you feel like you're just simply going to work better if you just follow along with me, that's totally fine too. But let's just go ahead and dive in and see what we get. So if I look at the first question on the mid-module assessment, right on number 1, right below where it says name, it says, for each of the following, identify whether or not it would be a valid statistical question you could ask about people at your school. Explain for each why it is or is not a statistical question. So let's recap before we jump into these what it takes to be statistical or not statistical as far as questions. If you want a question that is statistical, it has to be a question that you're going to be able to get more than one answer for. Typically, answers that involve you polling a class, like polling a group of people. In other words, you know how polls work. You ask multiple people and you get your answers, and it's kind of like a vote. Think of it more like a vote. Those kind of questions would be statistical questions. But if you just walk up and ask someone a question that only they can answer, and that's the only answer you're going to get, that is not a statistical question. So with that in mind, let's read each of these 4 questions on the front page on number 1, and we will say whether it's statistical or not as far as the question and explain why. And honestly, the explanations really they don't have to be too complicated. If you want to make your explanation long and more drawn out, that's fine. I'm going to more cut to the chase on the ones I have, because honestly, there's really just a central idea that I want to make sure we're focused on knowing that helps us determine if it's a statistical question or not. So the first question says, what are a typical number of hours of television watched by students at your school last night? So if I were to look at this question, think about that. What that's saying is, if you go around your school and you ask different kids, hey, how many hours of television do you watch? And you ask multiple kids, is every kid probably going to tell you the same thing? Most likely no. Some kids might watch a couple hours, some may not even have television. They may not have cable. They may not watch TV at all, or maybe they just don't like TV. And some may watch it for several hours before they go to bed. So that is what I would consider a good statistical question, because you can get multiple different answers from that, and you could get some pretty good data analysis from that. You could probably get some pretty spread out answers and could look for patterns there. So I think that's a great example of a statistical question. So on letter A, I'm going to say that it is statistical. It is statistical because asking multiple students, in other words, more than one student, or more than one student, because asking multiple students can give you different responses or answers. And I'll put in parentheses, or answers. So that's how I would explain number 1. You might explain it a little differently, but that's just how I choose to do it. So it is a statistical question, or it is statistical because asking multiple students can give you different responses or answers. So number 1 is statistical. Okay. All right. If I move on number 2. Number 2 says, what is the school principal's favorite television program? So think about that question. That's like if we were at school and we went to Miss Jones and said, hey, Miss Jones, what is your favorite television program? You are most likely gonna only get one answer from her, because someone's only gonna have one favorite. They're only gonna have one favorite television show if you follow that limit, if we're assuming that you can only have one. So Ms. Jones would only tell you one possible answer. So would that allow you to collect data and do a statistical analysis? No, because you're only getting one answer. So is this a statistical question? I would say no. So I'm going to put it is not statistical because you would only get one answer or response, however you want to say it. But you can't do a data analysis if you only have one answer. So it is not statistical Let me fix that just a little bit. Sorry, my pen is not working the greatest right now. It is not statistical because you would only get one answer. All right. So there's a second one. All right, two more. Let's see what we get on the next two. Do most students at your school tend to watch at least 1 hour of television on the weekend? Okay. So, again, here's a scenario where you would be walking around the school and you would be asking each student that you could catch, hey, do you watch at least 1 hour of television on the weekend? Now, are you only going to get one possible answer asking multiple students if they watch at least 1 hour of television? No, because even if it's as simple as a yes or no answer, you're going to get some yeses and some nos. You're going to get multiple responses, more than one response. So you could analyze that because you have multiple answers to look at and to look for patterns for. If you were trying to figure out, maybe you wanted to have, there's some show that you were wanting to create and you're trying to figure out, is it likely that someone would watch it if I put it on the weekend or on Saturday or something? It would help you to do a data analysis and figure out how many kids actually watch a decent amount of TV on the weekends. Because if they don't, it probably wouldn't do you very good to try to put a show on the weekend because there wouldn't be a lot of kids around to watch it. But if you ask those kids that question and a lot of them say yes compared to no, then you can look at that data you collected and say, okay, maybe it would be a good idea to put my show on the weekends because then there's going to be a lot of kids that potentially might watch it. So I would say even though there's only probably going to be two possible answers, either yes or no, that's statistical because you're going to get more than one answer, or answers are going to vary, as you would say. So I would say that it is statistical because you can get multiple answers, or we'll just leave it like that. Multiple / different answers or responses, again, however you want to say it. So on C, I would say it is statistical because you can get multiple or different answers to that question. Okay. The last one, guys, says, what is the recommended amount of television specified by the American Pediatric Association? So you can think of the American Pediatric Association as it's an organization that kind of comes up with different guidelines of certain amounts of things kids should do or should avoid doing, just kind of health guidelines, I guess you could call it. Because there's a lot of discussion about how healthy television can be, how a lot of people say you should avoid watching too much of it. Could have different issues with sleep and stuff like that. So obviously then if television can cause issues, if you do too much of it, they're going to put limits. The American Pediatric Association is going to put limits on how much you can watch just so you make sure you're staying in good health. So if you just simply ask, what's the recommended amount of television specified by the American Pediatric Association, they're only going to have one possible answer to that. Maybe it's, 2 hours. Well, if I want to know the answer to it and I go on their website and I see that the answer is 2 hours, is it possible if I only check the American Pediatric Association to get any other type of answer other than 2 hours? No, it's not. And so does that if I can only get one answer from that question, is that a statistical question? No, it's not. You can't do data analysis with one answer. So once again, I'm going to go ahead and just honestly copy down the same response that I did on part B when they asked about the principal's favorite show, simply because they have the same explanation. It is not statistical because you would only get one answer. You would only get one answer. And that is it for the first page. So on the last one, it is not statistical because you would only get one answer. So it looks like we had 2 and 2. Two of our questions ended up being statistical questions, A and C, and then 2 of them were not, B and D, because they only gave you one possible answer, so they can't be statistical. Okay. All right, that's the first page. So let's go ahead and get to the next page. So if I look at the next page on number 2, says in 2013, there were 9 judges serving on the Supreme Court of the United States. So think of the Supreme Court as like the biggest, the highest level of cases that you can have. Like if someone's going to the Supreme Court about something, then it is a very serious matter. So typically the best of the best are the people that land on the Supreme Court, because obviously they have the highest responsibility because they are making decisions on the biggest or what are deemed to be the most important cases in the United States. So big deal here. So it says in 2013, there were 9 judges serving on the Supreme Court of the United States. The following table lists how long, and then the number of years, in other words, each judge has served on the court as of 2013. So most likely, it's been a little while since this list has happened, 2013, about 7 years ago. So probably if you went back, look at this table today, some may not be on there anymore. And for those that are still on there, obviously they're going to have more. But we're just basing this on if you just stopped it at 2013, how many years of service would they have? So they give you several judges. No need to name them all. On the left of the table and on the right side of the table, they tell you the length of their service. So in other words, they give you the name and how long they've been doing it over on the right. So it says calculate the mean length of service for these 9 judges and show your work. All right, again, great test here in the middle of this unit. Do we remember how to do mean? Well, we should. Remember, mean stands for what? Mean stands for average. So when we're looking for this, there's 2 steps. First, we add up all the numbers. And then second, we divide by how many numbers we just added up. So I'm going to go to the column of that table that shows me length of service. And I'm going to first start by adding them all up. So I got 27 plus 25 plus 22 plus 20 plus 19 plus 8 plus 7 plus 4 and plus 3. Now, remember to pause before you add them up, because if they tell you how many numbers you're supposed to have, go ahead and check and make sure your list that you're adding has all of those numbers. For instance, it told me on this problem on the top row that there were 9 judges on the Supreme Court. So it'd be a good idea right now to check and make sure, did I add 9 numbers together? If I look, let's see, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So I got them all. So I'm going to go ahead and add them up. And I'm going to save a little bit of math here. If you do add those up, you end up getting 135. All right, so the total, 135. If I add all of those up, all the numbers on the right side of the table, I get 135. Now, That's not quite my mean yet. All I did was the first step. Now I got to divide by how many there were. And like we were mentioning, there's 9 judges, so I need to divide by 9. So to get my mean, I'm going to do 135 divided by 9. And if I do that, I do get an answer of 15. So my mean was 15. That means on average, those judges in that table are averaging about 15, or exactly actually 15 years of service. Okay. So the next thing they ask, and this is what we talked about yesterday, new idea, but I think we can handle it. Calculate the mean absolute deviation, or MAD, of the lengths of service for these 9 judges. Show your work. Well, here's what I would do first. I am going to write down the numbers that I used on the last problem. 27, 25, 22, 20, 19, 8, 7, 4, and 3. Okay. Then, so here's what let me pause real quick. Here's what I've done so far. On the next one, all I've done down here is list the numbers, put them side by side. And then I'm just going to compare them all to 15 and write how far, right below them, I'm going to write how far each of these numbers are from 15. If I look at 27, 27 is 12 away from 15. So I'm going to put a 12 right underneath. And also I'm going to put a line before I keep going. So I'm just going to put a line there so we're not getting a little too confused. But our original numbers are up here. And below the line is going to be how far are these numbers up here from the mean. Okay, so 27 is 12 away. 25 should be 10 away from 15. 22 is 7 away from 15. And you can, guys, if you are having some issues figuring how far these are from the mean, use calculator, use your phone. I'm just doing basic subtraction on it. Nothing complicated about it. 20 is 5 away from 15. 19 is 4 away from 15. 8 is 7 away from 15. 7 is 8 away from 15. 4 is 11 away from 15. And 3 is 12 away from 15. So now I've got all the numbers, all the deviations, I guess you would call it, down here. These are all the distances that each number above them is from the mean. So now, how do I get my mean average deviation? Well, we got 2 steps. Keep in mind that mean average deviation has the keyword mean in it, which means at some point we're going to have to find the mean of something. Well, we created a list down here below that line. Well, if I need to find the mean, well, sounds like we could just follow similar steps up like we did up here. But instead of using the top row, we'll go ahead and use the numbers that are telling you how far they are from the mean. And we'll do the same thing. We're going to go ahead and just add them all up. 12 plus 10 plus 7 plus 5 plus 4 plus 7 plus 8 plus 11 plus 12. And if I do that, I end up getting a total of 76. So if I add up all the numbers down below, I get a total of 76. Now, how do we finish off mean? Once we add them up, we have to divide them by how many numbers there are. Well, there were 9 judges, so there's going to be 9 distances from the mean on that list, like there were 9 numbers for the judges' years. So I'm going to take that 76 in order to get my mean average deviation, which I'm going to abbreviate as MAD. I'm going to take 76 and divide it by 9. And again, to save us some work here, I'm going to just estimate this a little bit because you're going to get a decimal here. But you should get a decimal of about 8.44. About 8.44. And what I'm going to do is I'm going to write that I'm going to use a kind of a new symbol. We haven't talked much about this, but let's get into it right now. So if you notice, instead of putting an equal sign, I use some like wavy lines. So what that means, whenever you see wavy lines instead of an equal sign, like I have an equal sign up here, but I made these wavy on purpose. If you ever have wavy lines like that, that means you're approximating, you're estimating. So if I estimate this, in other words, I don't write down every single number I would get for a decimal. I just kind of round it. I get about 8.44. So think about what that's telling you. That's telling you, on average, these numbers up here average about being about 8.44 away from the actual mean. Now, we're going to use that number to kind of help us answer the last question on this, because it asks a good question at this point. And I think this would be a great example of showing the use of knowing the mean average deviation of something. It says, explain why the mean may not be the best way to summarize a typical length of service for these 9 judges. So, in other words, if I were to come up to you and say, hey, I have this table that has how long these 9 judges have been on or have been serving on the Supreme Court. I'm going to tell you what the mean is and see if you can tell me how long you think one of them has been serving. And you're like, okay. And I say, all right, the mean is 15. If I tell you the mean is 15, you're probably going to pick some number close to 15, right? Because that's the clue you're given. If the average is 15, probably something's going to be close to 15. But look at the numbers you get. Most of these numbers are not even close to 15. 3, 4, 7, 8, those are pretty far away. 19 and 20 are relatively close. But then we go even higher, 22, 25, 27. Most of these numbers don't even come close to the mean, relatively speaking. The only reason that the mean ended up being at 15 is because you had a lot of big numbers and a lot of small numbers, and they averaged out into the middle. So with that in mind, if I told you the mean was 15, do you think it would be a good resource to predict how long some of those judges had been serving? I would say no. And what we're going to get into also is we're going to talk about how the mean average deviation might help you there too. The mean average deviation we found was 8.44, right? Well, if the mean is 15, and on average, these numbers up here, average being about 8.44 away from the mean, that sounds like those numbers are not staying very consistent with the mean. It sounds like they're fluctuating pretty far away, because if the average is only 15, 8 is a pretty significant difference. So I would say, and we only have 12 full sentences, but I would say, well, we'll go ahead and be proper about it. I'll say the mean is not reliable because most of the numbers are pretty far. I would just write it like that, pretty far from the mean of 15. And then I'll put a few in parentheses, like 3, 4, 25, 27, etc. etc., etc. etc. again just means that there could be more. I'm just not writing them all. So, like we're saying there, the mean, let me get on here. The mean is not reliable because most of the numbers are pretty far from the mean of 15. And I just gave some examples of some numbers that are pretty far from that mean. So I don't think the mean's a very reliable source on this one. Okay. So we're halfway done with the notes here. Got just a couple more pages, and then we'll talk briefly about your assignment. I will give you an example to help you out to get going on that assignment as well. And we will look and see what we got. So if I look at the next page, this one is going to have us practicing some dot plots. So it says, let me pull it up here. The following table displays data on calories for several Chinese foods from the Center for Science in the Public Interest, tabulated, which you can think of as maybe calculated or put together by the Philadelphia Inquirer. So they give you several options on here. If you look at your table, a lot of different food choices. They give you the name of them. They give you how big the dish size is and how and so sorry. And they give you how many calories there are. Okay. So it says on part A, round the calorie values, round the calories values to the nearest 100 calories and use these rounded values to produce a dot plot of the distributions of the calories in these dishes. So there comes an idea again that have been popping up here and there throughout the year that maybe some of you would have thought, okay, I'm done doing that. That was from a few years ago, but nope, here it comes again. We have rounding in this situation. So what we're going to need to do first is we're going to have to round each dish to the nearest 100 on their calories. Now, here's what I would do. Honestly, I don't particularly like how they wrote this table down because they don't really give you a lot of room to round, right? There's not a whole lot of space between columns. So here's what I would do. I would round these numbers right here and put them right beside their columns there. And I would take these numbers here and I'd put their rounded answers over there, over on the outside. And I'll go ahead and write that down to help us out. So keep in mind, you're rounding to the nearest 100. Well, on egg roll, if you have 190 calories and I'm rounding to the nearest 100, that should round up to 200. Okay. And please forgive me if I'm saying some of these wrong. Mushu pork had 1,228 calories, which if I round to the nearest 100 is 1,200. Kung Pao chicken had 1,620 calories, which should round to 1,600. Sweet and sour pork had almost the same exact calories, 1,613. So it is going to round to the same number, 1,600. Beef with broccoli had 1,175 calories, which should round to 1,200. General Tso's chicken had 1,597 calories, which should round up to 1,600. Orange crispy beef had 1,766 calories. There's a pretty big number there. It might be the biggest one on here. We'll find out. But 1,766 will round up to 1,800. 1,800. And then hot and sour soup seems like a lot healthier option, but same time, we'll talk about that here in a bit. But it only had 112 calories, which will just round down to 100. So if I'm rounding my calories over here, if I can get my pen to work, those numbers are going to round to these over here on the right. I rounded to the nearest 100. Okay. Now I'm going to do the ones on the other side of the table. So if I look at, again, here we go. I'm going to try to say these as best as I can. House lo mein had 1,059 calories. If I round that to the nearest 100, it should be 1,100. House fried rice had 1,484 calories, which will round up to 1,500. Chicken chow mein had 1,005 calories. Pretty easy one. Just rounds back down to 1,000. Hunan tofu had 907 calories. Again, pretty easy. It'll round back down to 900. Shrimp and garlic sauce had 945 calories, which will round back down to 900 as well. Stir-fried vegetables had 746 calories, which will round back down to 700. And then here we go again. Szechuan shrimp had 927 calories, which will round down to 900. So here are my rounded values on the right for those choices. So now I have all the numbers I need to move on. So please, if you need to copy those down, please feel free to pause the video back there to get your numbers written down. But now here's what I'm going to do. I'm going to take those rounded values that I just wrote down, and I'm going to use it on my to make a dot plot like the next question says. Because it says on A, round the calorie values to the nearest 100 calories and then use these rounded values to produce a dot plot of the distribution of the calories in these dishes, like we already said. So I'm just going to go through here and I am going to start plotting them. And I'm just going to start, guys. You can do however you want. You can try to go in order if you want. Doesn't matter. But I'm just going to start here and plot them all, work my way down the list, plot all these, work my way down the list. And just for kind of variety's sake, I'll use dots this time. I'll keep it a little more accurate and just go with dots. So start with 200. Pretty simple. Put a dot above 200. And I'm just going to cross the name of the dish off. So I'm going to cross egg roll off. And I got 1,200, 1,600, 1,600 again, 1,200 again, another 1,600. There's the big one, 1,800. That turned out to be the largest one, it appears. Only 100, so that'll land between 0 and 200. Also, I'm going to pause right there just because I did forget one little detail, and I apologize for that, guys. So far, I have done every number on the far right side, but I forgot to mention how I am labeling this. What I did was I made a dot plot, and I started over there at 0. Let me fill that in just a little bit better for you guys. Started over there at 0. And I counted by 200s all the way up to 1,800. And as you can see, so far, it's working out pretty well for me because it's pretty easy. If it doesn't land exactly on one of the numbers, it'll go, if it's 100, it'll just go halfway in between the two that you're looking at. So I think that's a pretty good way to count to make your dot plot. And you could have, if you really wanted to, counted by every 100 from 0 to 1,800 if you wanted to, or 1,800. But I just decided to make it a little simpler looking because it's not hard to estimate hundreds when you're counting by 200s. So I just decided let's make it look a little simpler, a little less complicated, and just save ourselves some writing. Instead of having to write all those hundreds, you can skip by 200s. So now I'm going to do the right side. I have 1,100 on the far right side, so that's halfway between 1,000 and 1,200. And then I have 1,500. It'll be halfway between 1,400 and 1,600. Then I have an easy one. I have 1,000. And then I have two 900s, one on Hunan tofu and one on shrimp and garlic sauce. So those two are gone. Then stir-fried vegetable is 700, which will land between 6 and 800. And then one more 900 for the last one, which I'm not even going to attempt to say a second time. And that would be at 900 again. So if I look at my dot plot, it should look something like this. Fairly spread out data, as we can see. Nothing really stuck out as really big. If we're talking about variability, I would say this is a fairly high variability just because of how stretched out it is. But we'll take a look a little closer into it and kind of get a little more specific about some details about this dot plot. But there's the dot plot. Now we're going to answer a couple questions. It says to describe the distribution of the data or of the calories in these dishes. So in other words, we're looking for patterns in here. But what do you see about the numbers where they land? One, to some stand out as like, do they clump up somewhere? Or do most of the dots kind of form, or do they kind of get plotted in a certain area? Or are they all just kind of spread out with no real pattern? To some seem bigger or smaller than others, etc. So we're going to come up with two ideas. We're going to start with where does it seem like most of the dots kind of focus around, if anything. For me, kind of honestly, guys, kind of hard to tell. There's not really a great answer on this one. If I could say anything, I would venture to say that a lot of them kind of, there's several of them kind of congregate right here in the middle between 900 and 1,200. So I would just go ahead and say that. I'm going to make 2 bullet points. One would be that there's a cluster between 900 and 1,200. So I'll say that cluster between 900 and 1,200, and I'll go ahead and just kind of circle that area so you know what I'm talking about. I know cluster's kind of new to us. Draw an arrow to it. So that's what I'm talking about, cluster between 900 and 1,200. And then another idea. Okay, here's kind of a new thought. But do you see any points on this graph, or sorry, this dot plot, that appear to be, that kind of stand out as kind of away from all the other ones? So take a look at it for a sec. Because I do see at least one. I actually see 2. If I were to look at this, these, I mean, there's some over here that kind of move away, but they don't get, none of them get like too far from the next one. But if you look here, there's a pretty sizable gap from here way over to there. So I would say that these two kind of stand out as far as being a lot bigger or smaller than the others. And if you look, a lot of these are in the thousands or close to 1,000. 700 is relatively close to 1,000. Thousands over here, but you have a 100 and a 200. Those kind of stand out as pretty low calories. So I would say on a second bullet point that 100 and 200 are a lot smaller than the rest of them. Okay. So 100 and 200 are a lot smaller than the rest of them. And I'll go ahead and circle those two. Just kind of draw an arrow so you know what I'm talking about. So that's more what I'm getting at. These two seem to stand out as way smaller than the rest. And I'm going to put a new idea that we haven't really talked about. I'm going to put in parentheses at the end of that second bullet point, possible outliers. So when we're talking about outliers, really what we're saying is that they outliers are numbers that just kind of don't seem to fit the plot. They kind of stick out as away from the group a little too much. So I would say if there are outliers, which we'll get to more later, it would be 100 and 200. So that's what I would say about that. Those could be outliers. They do seem to be noticeably less than anything else, bigger or smaller. So a couple more questions on here, guys. We're getting close to the end. So suppose you wanted to report data on calories per cup for different Chinese food. What would be the calories per cup for Kung Pao chicken? Okay, let's think about that idea. This kind of is going back way back to the beginning of the year when we were talking about rates. Because remember, a common thing you're going to hear when you're dealing with rates is something per something, miles per hour, feet per second, yards per hour, whatever. But think about what the word per is. So what did the word per often tell us to do? Something per something. Often it told us division. So if you look at this question, it's talking about calories per cup. We want to deal with calories per cup. So I'm going to actually just underline calories per cup, and I'm going to kind of give it an explanation of what you do on it. If you want calories per cup, you have to take the calories and divide by the cups. So calories per cup is calories divided by cups. And they want Kung Pao chickens. So I'm going to have to look in that table and see if I can figure out how many calories Kung Pao chicken has and how many cups it took to get it. And keep in mind that we are not using the rounded numbers at this point. So if I look at Kung Pao chicken, it has 1,620 calories on Kung Pao chicken. Okay? And there are 5 cups. In other words, it takes 5 cups to get those 1,620 calories. So if I want to know how many calories per cup it takes on Kung Pao chicken, I'm going to take the calories, which I'll write the number right under the word calories, and I'm going to divide by how many cups it took to get that many calories of 1,620. So to get my answer, I'm going to have to do 1,620 divided by 5. And if I do my calculation on that, that should give me a total of 324 calories per cup. And I'm going to write it a little different and then explain it up here. So I get 324 calories per cup. And this right here, if I write it like a fraction, calories per cup is calories over cup. These two are the same thing. Okay? So in other words, I could put a double arrow. These are the same way to say calories per cup, calories over cups. So there's my answer on the next option. It should be C. Okay. Okay. So if I move on to the next question, it says, could you calculate calories per cup? And this is on the 4th page. So we moved on to the 4th page. We're going to answer the 4th page and stop there. It says, could you calculate calories per cup for all the foods listed in the table? Explain why or why not. Well, all you need is calories and cups. If I look back at this table, okay, this side looks good. All have cups and all have calories. Check the other side, because the question says, can you do it for all the foods? Well, here's calories on the other side. But look right here, cups up. Not here. If I look here, it actually says 4 pancakes. Interesting difference there. They go from cups to pancakes. So, and actually there's another one outlier here too. If I also look right here, the first one is a roll. So can I do calories per cups on every one of those according to the table? No. So I would put on part D, no, you can't do, I would say you can't do it for, looks like egg rolls. And I'm going to put in parentheses that it would be calories per roll. Or you also can't do it for Mushu pork or Mushu pork. Okay. And that one would be calories per pancake. So that would be my answer on D. You can't do it for all of them. Most of them you can do calories per cup because they give you calories in cups, but those are the two that you cannot do it for. All right. If an E says if you want to compare the healthiness of these foods in terms of calories, would you compare the calorie amounts or the calories per cup? Okay, good question. So they're saying, in other words, is it more reliable to know how many calories something has or how many calories per cup? Well, just to look through here a little bit, as I scan through them, but I'm just going to look for a good example here of ones that might not be as reliable. So here's a great example. I'm going to compare house fried rice with stir-fried vegetables. All right. I'm going to choose those two because they both have 4 cups, but they have different calories. This is saying in 4 cups, you're going to get 1,484 calories. But this one's saying in 4 cups, you're going to get 746 calories. This one is giving you the same amount of food as this one up here. You're getting way more calories for the same 4 cups as you're getting down here. So this one on stir-fried vegetables is going to give you a lot less calories for the same amount that the house fried rice will give you, which makes sense because typically fried foods can be higher in calories, not as good for you. It would make sense that you're going to get less calories out of the vegetable option. So I would say that calories per cup is more useful because some of the food choices have the same amounts of cups, but one has way more calories than the other. So I would say calories per cup is a better indicator because if you just want calories and you try to do that, some of the food choices have the same amount of cups, but one has way more calories than the other. So clearly, you can't just look at the number of calories and find the highest amount of calories and say, okay, that's it. That's the one that's the best or worst for you or has the most per amount. You have to consider how much is it taking to get that amount. So that's what I would say on part E. Now let's look at one more question here, number 4. We're going to do A and B on it. So if I read it, it says a father wanted some pieces of wood that were 10 inches long for a building project with his son. Sorry. He asked the hardware store to cut some longer pieces of wood into 10-inch pieces. However, he noticed that not all the pieces given to him were the same length. He then took the cut pieces of wood home and measured the length in inches of each piece. The table below summarizes the lengths that he found. So here's the table. And I'm going to fold that just so we're all focused on the same idea here. Don't want us to be getting confused with what we're looking at. There's my table. And it tells you the ranges up here of how long the pieces are. And it tells you how often those pieces showed up. So just kind of look at this a little bit. If I'm looking at these, kind of zoom it in here. This is saying that any piece from anywhere from 8.5 to 8.75, he's got one of them. 8.75 to 9, got looks like 2 of them. And then from 9 to 9.25, got 2 of them. And it looks like, if we look carefully at this, guys, that he's always going up by a quarter. Like 0.25 is how much he's going up each time from each range, all the way until he gets between 12 and 12.25. So anything that lands between 12 and 12.25. So they say on part A, create a histogram for the data. So here's what I went ahead and did, guys. My histogram, if I label it, I'll give you all, and please, if you need, pause the video here and copy down what I put here. But what I have here is I have a histogram where it tells me at the bottom, along the bottom line, I'm counting up by halves: 8, 8.5, 9, 9.5, 10, 10.5, 11, 11.5, 12, 12.5. And notice that in between each of those halves, like between 8 and 8.5, I put a line to allow myself to cut it into quarters. Because look right here, between 8 and 9, if I look at that, if I'm trying to make a histogram, which is a bar graph, I have 1, 2, 3, 4 sections between 8 and 9. If I have 4 sections between 8 and 9, that means I successfully cut it into quarters. Same from 9 to 10. 1, 2, 3, 4. Same from 10 to 11. 1, 2, 3, 4. 11 to 12. 1, 2, 3, 4. And I only went from 12 to 12 and a half here, so it just needs 2 quarters. Okay, and that's the lengths in inches. And then I put just frequency. Remember, frequency just means how often did it happen. And I counted up to 6. So if we look too, the reason I counted up to 6 is because the highest frequency appears to be a 6 if I look at all these numbers. So once I labeled it, now I don't really have to do much more on this. All I have to do is just make bars in each section that show how tall they're supposed to be. So if I start here, 8.5 to 8.75, that should be the column or the grouping that is right after the 8.5. So 8.5 to 8.75 should be this section right here. And I only have one of those, so I'm going to just make a bar that goes up to the number, approximately up to the number 1. So it'll look something like that. Then it's just going to, from what I'm seeing here, I don't really see any gaps. It looks like it's just, well, there will be a gap eventually, but for now, they're just going up one section at a time. So the next one is 8.75 to 9. And I see that it happens twice. So there's the next one, 8.75 to 9. Happened about twice. And then 9 to 9.25 is the very next one. It's 2 again. So I have 2 bars that are the same height. Then the next one is 9.25 to 9.50. Well, this one's 4, so I'm going to go up to 4. And again, I'm just kind of estimating the heights here, guys. You don't have to be completely perfect. Just try to get it as close as you can get it on these. This should be about twice as tall as the previous two because it had 4. And then I have 9.50 to 9.75 is at 3. So I'm going to mark it at 3. Again, if you notice, they haven't skipped any ranges yet. They've just been going from one to the next so far. So you don't have, so far you're not having any gaps in your bars. They're all going from one range to the next. Then I have 9.75 to 10, which is only 2 again. And it's nice when you've already have a 2 on your graph because then it's a little easier to visualize how tall to make it. And then I have, let's see, 10 to 10.25 is a 5. So got a lot noticeably taller here, going all the way up to 5. Okay. Then I have 10.25 to 10.50 is at 6. So there's the peak. It's going to go all the way to the top of my histogram. All the way up to the top. So now let's pause for a second. If I keep going, the next one, we're still following the pattern. Next one is 10.50 to 10.75. So we can keep going and not skip anything. And this one only has 1. So it's going to be way back down on the 1. So here's where we're going to pause, though. What we're going to pause here is that last one said 10.50 to 10.75. The next one should be 10.75 to 11. But if we look, they skip all the way to 12 instead of 10.75 up here. So I am going to have to skip all the way over. It says 12, so I'm going to start right here at 12, and I want 12 to 12.25. So I want this section right here. And it only gets a 1. So with that, my histogram is complete. Or something like that. Okay. So there's my histogram. That's what it should look like. All right. So now that we're at this point, guys, I'm going to go ahead and just stop here because the next question talks about describe the shape of the histogram. Don't worry about that yet because we haven't talked about shapes of histograms just yet. We will get to that here eventually, fairly soon, but we can stop there for now. So here's what I want to do as far as your assignment, and I'll post it on Google Classroom, but I want to test what you guys know about mean. So I'm just going to pull the question up and read it real quick for you guys. So the question that you guys have, and when I post it, it'll be a number 5. So it says, suppose you are timing how long it takes a car to race down a wood track placed at a 45-degree angle. The race for the times for 5 races are recorded. The mean time for the 5 races is 2.75 seconds. That means if you raced 5 cars and you average their 5 times, you get an average of 2.75 seconds. So what is the total time for the 5 races? The times of the 5 races summed together. So I'm just going to give you an example of how to approach this question, guys. So let's say, I'll keep it simple. Let's say I had the numbers 4, 6, 3, 7, 8, 2. All right, I gave you that list, and I said, okay, find the mean of that. Well, if I added them all up, 4 plus 6 plus 3 plus 7 plus 8 plus 2 should give me a total of 30. So I add it up. Now, if I want the mean, it appears that I have 1, 2, 3, 4, 5, 6 numbers. So if I want the mean, I'd have to take 30 and divide it by 6. And if I do that, I get a mean of 5. Okay? Simple enough. Now, here's the point. Let's say all I knew is that I had 6 numbers and their mean was 5, and someone told me, okay, now figure out what the total of all of them put together would be. Well, if my mean is 5, that means the average of all of these is 5. So if I didn't know what these numbers are, and I was trying to figure out what their total was, if I know their mean is 5, that's the same thing as saying every number has an average of 5. So I could just change all the numbers to 5s. Not really technically changing them. But if their averages are 5s, that's saying that all of them put together, if they all average a 5, this still has an average of 5, right? If I add up a bunch of 5s and I say, what's the average of that? It's 5. So I just made up another list that would have an average of 5, right? So this is just another example of a list that has the same average as this list up here. Because if I add all these up, they're going to give me 30 as well. And if I do 30 divided by 6 again, I get 5 a second time for my mean. So in other words, if they're giving you a list, if they're giving you a mean of a set of numbers, and they tell you that the mean is 2.75, or like on this one, it's 5, keep in mind you could rewrite a list that has nothing but your mean in it. And knowing that, I was able to get the total right there just by turning everything in my list into whatever the mean was. And then I was just able to add it up and get the total. So think about, I know that's not totally exactly what's going on, but I think it's a pretty decent connection. I'll be happy to try to explain it a little bit more, but I would like y'all to attempt to answer question number 5 with that information right there. Just kind of find the pattern of what I'm talking about here. Similar idea, and let's just see if you can. Again, guys, that's just kind of an example I came up with. If we need, I'll happily come up with other ways to help us better understand it, and we'll just see how we do on it. But please do your best. Please get that turned in, and we'll see what you guys think, and we'll see how many people got that one figured out. I think that'll be a nice challenge question to try. And for this one, guys, also it says on part B, suppose you learn that the timer malfunctioned on one of the 5 races. The result of the race had been reported to be 3.6 seconds. If you remove that time from the list and recompute the means for the remaining 4 times, what do you get for the mean? Here's what I'm going to say. Let's skip B. I just want to see if you guys can figure out part A on that. I'll talk about point B with you guys. But for our assignment, let's just make it part A. See if you can figure out part A. So I will try to edit that a bit too on the paper. I'll just go ahead and put skip B. So just focus on trying to figure A out, and we will go over it. I may start the next class video going over that one, but we'll get to that when we get to it. So that's all I want to cover today, guys. Give that one a shot. I'll have it marked under homework again, just that one problem. And keep in mind, quiz on Friday on quizzes that we'll be doing. And just to kind of recap what that is, just take a look at my notes real quick. The quiz will be over practicing dot plots. So be prepared. Look over the stuff we've done for dot plots so far. And it should be pretty easy, guys. I don't think it'll be a very hard one, but it'll be just a nice little test to see how well we're understanding the dot plots. So that's all I got today, guys. Please message me with any questions you have, and good luck on your assignment.